All right. So we begin our colloquium now. So it's a pleasure to have Professor Jigar Patel from Management Science Department at University of Miami, and he's going to speak on optimal product launches. So Jigar, over to you.
Okay. Thanks for inviting me. So when I was speaking with Agnit, he said that people who like to have a flavor of what type of research is done in business school and associate and research that kind of gives flavor to PhD students. So I've kind of tried to incorporate some math or at least a flavor of math that tells you the tools that we use to solve the type of problems that occurs in management science. So let me begin with the talk. So this work was done a couple of years back, and it recently won this Informs Time Society 2021 Best Paper Award. So that's based on a couple of last 5 years. Based on last 5 year citations of the papers that are published in Management Science Journal. And this is joint work with my co-authors at the time. So, okay. So let's talk about firms that launch products over time and products which are successive versions of the previous one. So firms launching successive generations of the product with incremental improvements. So think about these firms. These are so let's look at Apple. They launched a whole bunch of iPhones over time, iPads over time, and so on and so forth. And each phone is a improvement over the previous generation. So you can think of it as basically incorporating incremental innovation in a successive generations of the product. Right. Similarly, car companies, they launch better and better versions of car. Processor companies like Intel, AMD, Nvidia, they launch newer and better chips over time and such. Right. Microsoft launching better softwares over time. So the question that we want to understand here is, how should these firms launch the product? Subject to current demand environment. So to kind of anchor our talk in somewhat a realistic, to understand kind of with an example, I just give the example of iPhone. Right, so Apple released this original iPhone in 2007, and they've been releasing newer phones over time with better and better features. Right, so these are a bunch of features that we know. Like iPhone 3GS had some camera, then 4 had better display, and then Siri and this and that. And over more than 10 years of span, these people they have incorporated newer and newer features over time. So this is a kind of a supply side. We look at business environment where there is supply side, demand side. Supply side is these companies that release products over time, right? So supply side is companies, demand side is customers. So now you look at the demand side of this picture, where these are the sales numbers for iPhone. And if you see the trend of iPhone sales, there are these peaks and valleys, right? There are these peaks which you see here, 74.5 million units in Q1 of 2015, then 74.8 in Q1 of 2016, and so on and so forth. So these are the numbers associated. Why are these peaks and valleys that you see? The reason behind these peaks and valleys is that consumers are strategic. What do I mean by consumers are strategic? Consumers, they always kind of wait for the next launch. So basically, now given that there is a lot of information in the market, people kind of anticipate that newer version is about to come, and therefore they kind of hold off on the purchase to get the newer version of a product that they would like to buy. Right. So when Apple is about to launch a new iPhone version, sales slow down. So this is the picture that we saw, that people kind of hold off into the previous quarter, and as soon as the new phone is launched, they kind of buy that phone as soon as it's kind of launched. So that's why you see the sales peaking right after the launch. And this is kind of well documented that the customers have become strategic about their purchase decisions across the industries. So this is the phenomenon of kind of more information available at a cheaper rate, right? Because of internet, this and that. Anyone sitting in any corner of the world can kind of get this information that, oh, there is likely to be a new product coming within a week or 10 days or a month. So maybe I should hold off and get a newer product at a similar price as that of the older product. So there are evidences that there is ample evidence that consumers are strategic. So basically they play game, or they optimize their own utility subject to firm's behavior, right? So, and these evidences kind of it shows that Apple falls after weight for the iPhone 4 has caused iPhone 4 has caused missed estimates. So there are a whole bunch of then Tim Cook statements. There are incredible anticipation out there for the future product, and so on and so forth. There is evidence that consumers are strategic. Fair enough. So we are understanding, we look at these two sides, supply side and demand side. Supply side is companies need to decide what is enough innovation that I have accumulated in my R&D that I can bundle it together and launch it in a newer product. So that's firm's problem, that is company's problem. Subject to what is consumer's problem? Consumer's problem is to decide, well, company is going to launch newer versions of products over time. Which products, which iPhone should I buy? Right, so maybe depending upon your choices and utility, you might have bought, let's say, iPhone 10, and then you used it for 3 or 4 years, and then you bought iPhone 12, then you again used it for maybe 2 or 3 odd years, and then you bought iPhone 14. Right, so you didn't buy a couple of generations, but as a customer, you also upgrade your product over time. So this work looks at this research question, that given that consumers are strategic, right, they make informed choices about future product launches. How should a firm introduce new products? Right, so we look at a stylized model that kind of distills essential features of the phenomenon and try to understand what is the optimal launch strategy. Okay, should the firm launch a simple launch cycle or more complex one? Right, so this question of how much innovation is enough innovation so that I can bundle it together and put it in a new product and get as much revenue or as much profit as possible is an interesting question. Right, if you bundle too little innovation, that's not optimal, because people would think that this product is similar to the last one and I don't need it, so I wouldn't buy it. On the other hand, if you have a lot of innovation bundled in the next product, you as a firm might have thought, well, I could have rather involved 70% of this innovation and then later kept 30% innovation for the next launch. In that case, I would have made people buy more than once. Right, so too much innovation in a product, you are leaving some money on the table. Too little innovation in the product, you are losing the revenue because people are not buying the product. So what's the right amount of innovation to bundle? That's one question. And what is the policy here? Right, is it a simple enough? It's a complex policy. What type of policy? So we answer this question: what is the optimal launch policy in this infinite horizon problem? What's the optimal launch policy under two information structures? First information structure is where firm releases products on the go, as in they don't give any information in the market about what they are, how much innovation are they going to incorporate in the next product. As the time passes, they release new product. That's one information structure, which we call market, which is on the go launch policies. Second type of information structure that we look at is called pre-announcing. So pre-announcing the innovation levels. For example, a while back, if you look at Intel, they used to announce that they will have microprocessors which would have certain nanometer, like 7 nanometer chips. Then they will have architectural improvement, and then they will have 5 nanometer chips. Then they'll have architectural improvement over chips, and so on and so forth. So these are called tick and talk innovations. So they used to kind of lay down the path of the innovation and product launches that they were going to do. So that's kind of saying pre-announced type of things. So we'll look at these two information structures and characterize the optimal product launch policies. Okay. Are we okay with this so far, people? Do we have questions? Anyone?
So everybody, I think, can unmute and ask. So till then, Jigar, I think it's fine. So you can carry on.
Okay. So I'll kind of briefly, I'm just going to mention what's the related literature about the features that people look at and types of paper they write in management science. Then we'll talk about our model. And then we'll analyze optimal policy under this information structure, which I called on the go, right? So there is no information given in the market about the innovations of successive generations of product. So I as Apple, or I as AMD or Toyota or Hyundai, I don't tell anything what innovations will the next generation of the products will have. That's on the go information structure. And the second information structure is pre-announcing the product launches. Things like that Intel used to do, saying, oh, we'll have 9 nanometer or 7 nanometer chips, and then we'll have architectural improvements, and then the third one will be 5 nanometer chips, and fourth one will be some architectural improvements, so on and so forth. So these two are this on the go is one information structure. We'll analyze optimal policies there. We'll analyze optimal policies under pre-announcing. So these two are the information structure. Once we kind of figure out the optimal policies under this, then we'll generalize model further. We'll do price optimization. So in the initial model, we'll assume that price is given. Then we'll say, okay, let's even optimize the price. And compare, once we optimize price, then we'll compare the profit under these two policies, right? These two information structures. Is on the go better or pre-announcing better? Then there are some more generalizations that, let's see if time permits, we'll talk about multiple consumer classes and some other things. So basically in management science literature, there has been a lot of work about how do you introduce new product. So there are management science people who do this. There are some economics people who do this. There are marketing science people who do this, and they kind of focus on different aspects of it, right? So certain product introduction under exogenous demand and myopic customers. So myopic customers, as in they don't, customers just evaluate their utility by buying or not buying one product. Right, they don't think about what is coming in the future and let me optimize my future utility subject to what's let me optimize my total expected utility considering the future launches and such. So these things, these are the customers who are not strategic, who don't optimize over the time horizon. These customers are called myopic ones. Right, then there are some environmental regulation related new product introduction paper, Rarica Plembeck and some. So there are a whole bunch of people who kind of focus on different aspects of product launches, and they look at different, and these people are in different community, as I said, in economics and marketing and strategy and all. So now let's focus on our model. So I'm going to go a little slow, and if there is some question, please interrupt me and ask me if something is not clear. So our model is reasonably simple to begin with. Let's assume a monopoly that is launching a product over time. Infinitely many consumers. So consumers are indexed by theta. Theta in 0 and 1. So mass is mass of consumers. continuous time, infinite horizon with common discount rate delta. At any time, you assume that there is just one product available in the market. So as soon as the newer product is launched, older product is phased out. This is just for the simplicity, and with even reasonably simple model, it will become quite intractable very quickly. And we generalize some of these things later, so just bear with me for the assumptions. Consumers buy multiple products over time, which is how things work. People buy multiple cars over time, people buy multiple phones over time, and such. Launch times, the firm launches products. These launch times are represented by vector tau. So bold Greek letters are vectors. So tau 1, tau 2 up until tau infinity. And consumer theta's purchase times are given by kappa. Kappa theta is in, let's say, I am a customer. I bought my first phone at kappa 1 time. Then I bought second phone as kappa 2, so on and so forth. So you can think of this as, let's say this tau 1 is the time when iPhone 10 was launched. And I bought after a few months of iPhone 10 launch at time kappa 1. Then there was iPhone 11 was launched at time tau 2, and I bought after a few months of that launch, that iPhone 11. Then let's say iPhone 12 was launched at time tau 3, and iPhone 13 was launched on time tau 4. And I bought that as soon as I bought iPhone 13 as soon as it was launched. So I ended up having, let's say, iPhone 10, 11, and 13. Okay. So technology follows a Brownian motion. What is this technology? This innovation that we say, okay, something is better camera, processor, and Face ID and NFC and all these things. We index it by a scalar, right? The amount of technology in a product. That technology is a Brownian motion. There are reasons to assume this Brownian or Poisson in the literature. So this is a Brownian motion with positive drift, right? We assume that this is increasing over time, and there is a stochasticity in it. Sometimes you kind of get setbacks and so on and so forth. So this is a Brownian motion ZT with drift mu and variance and the standard deviation sigma. So mu t plus sigma bt. Bt is standard Brownian. Market technology. What is market technology? Market technology is the technology of the latest product that you have in the market, right? So think of, let's say, Apple having launched iPhone 14. Whatever the innovation level of iPhone 14, that's the market technology of current time. Let's say WT, T is the current time, let's say, then WT is the technology that is accessible to customers, market technology. That's the technology of iPhone 14. But we can imagine that Apple has made some innovation since the launch of the product, and then their R&D value, the technology in their R&D is higher than, is actually ZT, which is now they have already made some innovations over iPhone 14 in their R&D. So that would be that ZT that you see here. So market technology is WT, and consumer theta's technology, right? C theta T are given by following. What is WT? WT is basically saying supremum of ZT when the launch happened. Last time when the launch happened, where T prime less than or equal to T in the launch horizon, what is the latest launch technology you have? This is simple. C theta T, right? What is the technology of the consumer? What is my technology? Maybe I own iPhone 13. So supremum of whatever market technology is available, last purchase I made, right? T prime less than T. T prime is in my purchase times. So for me, I bought my last thing whenever I bought my iPhone 13. So I own iPhone 13's technology, iPhone 13's technology. Right, so I just kind of want to show the picture also and explain what's happening. The blue is the Brownian motion ZT, right? At time tau 1, this Z1 technology was, the iPhone was launched at that time. and I bought, let's say, that phone at time kappa 1 theta. So I start getting utility based on the technology level I own. So that assumption that what is my utility, what is my joy of using product, what is a customer's utility, that is function of the type of technology or amount of technology you own. So I own at time kappa 1t, I start earning utility, I start getting utility at value Z1, right? There is some other phone that is launched at time tau 2, and that has technology level Z2, but I didn't buy it. So I'm just getting technology, my utility at Z1. Then some third phone was launched at time tau 3 that had technology level Z3. And I bought that phone at kappa 2, and I start getting my utility at the technology level Z3. Okay. So let's talk about the utility functions. The firm's launch cost is capital K, and this launch cost is amortized over customers. So think of it as the product launch cost divided by the number of customers. It makes arithmetic somewhat easier. No loss of generality there. So launch cost per customer, K. Unit production cost is C. Retail price is P. Naturally, retail price has to be more than K plus C, otherwise you wouldn't be in the business. Utility of the firm is given by following. This is not profound, this is easy. Let's see my utility. I am the theta customer. If I buy a single phone, I buy at price P. So we are talking about utility of the firm, how much firm gets from me. I pay price P minus C. C is the production cost for the firm. At what time do they get this money? The time value of money is e power negative delta at time Ki, right? The time when I bought this, time when I paid P dollars to the firm, minus K, the product launch cost, and that launch happened at time tau I. Correct? So my purchases are the summation P minus C, this inner summation included. That's the money that I'm giving to the firm, and integration over all the customers from 0 to 1. So this is the total revenue. This is the total revenue that the firm gets, right? Total revenue, first bracket is the money that they get from customer, P minus C, and minus the launch cost of all the product launches that you do over infinite horizon. Are we okay with this? Hopefully. Now let's talk about utility of consumer, right? So theta consumer, how much utility am I getting? So me as a consumer, I get utility at a rate of V. V is just a given scalar. For the time being, you can just assume V is V equal to 1. I get my utility at the rate of the technology that I own. So if I were using iPhone 4, my C theta is technology level of iPhone 4, which is pretty small compared to owning, let's say, iPhone 12, which has more innovations, and I can do much, but I can do more things with it and such. So that is the C theta T was, if you remember, was the consumer theta's technology that they own, right? So I get utility at the rate of the technology that I own. What is my utility? My utility is C theta T, discounting e power delta T dt over infinite horizon, right? Minus the amount that I paid. I paid price P, fixed price P. Assume that every single product cost P dollars. We can relax this later, but for the time being, assume that this is just P dollars. We optimize P over time. So P, so we keep P is constant in this model, in this paper itself, but later you will find out the optimal pricing associated with this. So I shouldn't have said we can change price, but this price changes over the successive product generation isn't as much. Generally, they are constant over reasonably long horizon. So amount of the price I paid over time right? I bought every product at time kappa I, and I paid price P. So this is my utility, right? The utility, the joy I get minus the price I paid. Are we okay with this so far, people? It seems okay. Any ambiguity in this? Okay. So now let's talk about this information structure that I was first information structure, where firm is just launching products on the go. There is no information available in the market about what they are going to do. They simply launch and consumers decide whether they want to buy or not. So we are looking at the first information structure, launching products on the go. Consumer theta's outdatedness is basically how much outdated product I have. Market technology, right? Let's say in market there is iPhone 14 minus what I have. I have iPhone 12. So this is my outdatedness. So the structure of market's outdatedness is this is composition, which captures the fraction of the market with each given level of outdatedness. For example, let's say current market is such that 40% of the people own the latest product and 60% of the people own product, let's say 2 units. Their outdatedness is 2 units or 2 generations. So think of it, they own, I don't know, iPhone 12. The state of the market at time t. What is the state of the market? State of the market is saying R&D level minus the market technology, comma the outdatedness of the market. Right. So this is saying how much accumulated technology does the company have with it, and the market composition. Right. What has market bought so far? The state of the market immediately before the time t is basically limit approaching from the left. T prime goes to T. Firm's Markovian launch strategy, right? So firm decides based on the state of the market whether to launch a product at any point in time or not. So strategy, this is a function of the firm that makes decision based on the market composition, based on the state of the market. How much innovation do I have accumulated so far as a firm, and what has market bought so far? Based on that, I make a decision whether I want to launch a product or not. So that's the strategy. This is a function of the market, state of the market. Consumer theta decides Markovian purchasing strategy. That's a mapping of saying, look, what's the market composition and what's my own outdatedness, right? So what does market have? This is the common information. And how much, what product am I using? So this is basically a function of market composition and my outdatedness to make a decision whether purchase or not purchase. So first, once you set out the problem, there is a reasonable, this is not a hard lemma, which says, look, what is the customer's best response, right? Customer's best response to threshold launch policies. So if we look at the firm that launches new products, as soon as their accumulated innovation in their R&D is bigger than some number, right? Let's say I have more than 5 units of R&D accumulated since the last launch, then let's say they launch a product. If that's firm's policy, if that's the way firm is launching the product, then consumers will purchase every release if and only if this incremental accumulation or incremental innovation is greater than or equal to some threshold, right? So basically, me as a customer will buy product only if it has more than Z star amount of innovation in the product. right? Where Z star is a unique positive solution, you can solve this. P is known, delta is known, V is known. So you can solve this. Capital delta is just function of, again, the parameters. So Agnit, how much time do I have? 15 more minutes, 20 minutes, 1 hour, how much?
So you have about 20 minutes definitely, but you can, so since we started a bit late, so maybe 25 minutes.
Okay, fair. Let me try to kind of distill more important ideas in 20 minutes, and then we can discuss further that we would like to. So fair enough. So what we are saying so far is, if firm is launching after every, let's say, 5 units of innovation, customer will buy a product only if the successive innovation is more than Z star value. So what happens in equilibrium here? Markov perfect equilibrium in theorem. Okay. So here's the theorem. So when I was doing PhD, I heard a talk in which speaker said every talk should have a theorem and a joke, and both should not be the same thing. So hopefully this theorem isn't a joke to you. So in equilibrium path of any Markov perfect equilibrium, product launches occur exclusively when the technology innovation is exactly Z star. Almost all consumers, almost all means the measure of consumers that buy the product is 1. That is this almost surely statement. Almost all consumers buy at every product launch. So what's going to happen in this on-the-go information structure? Here's what's going to happen. If company is launching products over time, they launch as soon as last product launch, last product's technology, and the product they have in-house in their R&D is Z star, and they would launch it, and customers would just buy that, right? So customers are strategic. All customers are strategic, so they would buy that product. So equilibrium path is the firm's optimal 1 cycle policy. So basically, every so often, a product will get launched and people will buy that product. This happens, remember, because we have assumed so far that customers have same base valuation V, right? So I assume that my joy of buying a phone is similar to someone else's joy. Later, we relax that assumption and say people have different base valuation V. In that case, if I am a person who uses phone very much compared to academics like other academics where they don't use phone much, then the person who has higher use will buy more frequently compared to person who doesn't have as much use. So that part is later relaxed. Right now, our model is reasonably simple. And full equilibrium is hard to characterize, but the equilibrium path is determined. So from our initial state, we can say, hey, I can characterize equilibrium path, and equilibrium path is this. Then in any equilibrium path of Markov perfect equilibrium, this will happen. Firm will launch every Z star innovation happens with them, and because the consumers will buy every Z star innovation. So consumers will buy that product. Okay. So could the firm do better with this, better than this with pre-announcing? And if so, how? So what we have done is said following. We said, look, if the firm was launching products on the go without giving any information in the market about their launch strategy, this is what would happen. Consumers will optimize their own utility based on their choices, and in this game between firm and the consumers, firm will launch product every so often, every time they have Z star innovation accumulated with them. So now the question is, can we do better? Can the firm do better? Can they extract more revenue than this? So that's where the second information structure comes in, where you do pre-announcing. You say, hey, so let's talk about these pre-announcing policies. Pre-announcing was this example where I said, Intel goes and says, we are going to launch product with these nanometer chips, and then we'll do architectural improvement. Then the third improvement will be another size improvement. And the fourth one will be again, some other improvements, so on and so forth, where they kind of lay down the path of what they are looking at, what they are going to launch. So so these are the pre-announced policy. The firm pre-announces a sequence Z, right? Z1, Z2, Z3 up until infinity of technology levels. So basically, the way example I said, Intel says we'll look at 9 nanometer or 10 nanometer chips, then architecture improvement, then 5 nanometer chips, and so on and so forth, some such things, where they announce these levels, Z1, Z2, Z3. It launches a product I at hitting time tau I of level Zi. So whenever the Brownian hits level Z1, they launch the product. Whenever the Brownian hits the level Z2, they launch the product, so on and so on. And remember, this is a Brownian with positive drift. We are going to hit all these levels, right? This is basically increasing sequence of real numbers, and we are going to hit all these at some point in time. And those are the time tau I's. Consumers solve a dynamic control problem to determine when to purchase, right? Always choosing an action as a function of Z. Right, so what is omega t? Omega t is the sample path that has realized so far. So innovation path, Z t prime, where t prime is less than or equal. So this looks like somewhat this is a challenging problem. So what is the problem? Let's just understand the problem. We are saying firm, right? Firm wants to maximize. So UF is the utility of the firm. Firm wants to maximize expected utility, right? Given that they are expected utility of their price path Z, innovation frontier Z, innovation technology levels, this Z, also incorporating consumer strategy, what consumers are going to do. So firm's utility function, utility, it depends upon what innovation levels they are going to commit to, and what is consumers' behavior. This is consumers' behavior. So firm wants to find out what technology level, right? What technology levels, at what technology levels they should launch the products. So firm's decision is to find out this sequence, this infinite sequence of real numbers, which represent technology level of each product, so that maximizes their expected utility. Subject to what? Subject to consumers acting optimally. Subject to consumers' utility, which is greater than any other strategy. So me as a consumer theta prime, right? I will employ strategy S theta prime, which is better than any other strategy S bar theta prime. So this is saying firm is maximizing their utility subject to consumers maximizing their own utility, right? Over all time horizons, over all possible sample paths for all customers, and over the strategy space of action space, over the strategy functions. Okay, fair enough. That's reasonably complex problem that needs ideas from applied game theory, submodularity, and a whole bunch of other techniques to kind of get to the solution of this thing. But the good part is this complex problem, this problem that we just spoke about, what are we doing? In math terms, we are saying, look, a company wants to decide the technology levels, right? This is a real sequence that gives them optimal, that maximizes their utility, right? So this technology level can be all prime numbers for all you know, right? It could be I'll release first product that is technology level 2, second product which is technology level 3, third product which is technology level 5, right? Technology level 2, 3, 5, 7, 11. So any possible real sequence. So which real sequence will maximize firm's utility subject to consumers acting, consumers maximizing their own utility. So problem is pretty complex, but we do some successive reductions and employ the tools of kind of different optimizations and sub-modularity ideas and such. And the outcome is pretty neat. So this is the major result of the work, which is there is a unique optimal launch policy, first of all, such that if your product has if in some fringe conditions, the condition that doesn't get satisfied most of the time, firm will just launch once and exit the market. Imagine a product that lasts long time and technology improvement doesn't happen much. In that case, firm doesn't have any incentive to launch more products. But the major practical parameter setting is such that, and this practical parameter setting, I'm simply saying because I came across a paper that kind of did work on this and said most of the time, for all practical purposes, this is how the firm will operate. This is how the real world will happen. Is saying, look, firm should launch new products in accordance with a 2-cycle policy, with cycles R1 less than R2, where R1 is the unique solution of something, R2 is unique solution of something, and these are easily figure outable, so to speak. What is this 2-cycle policy? This 2-cycle policy is very interesting. 2-cycle policy is very interesting. Let me see. 2-cycle policy is following. It says it follows the policy that iPhone or Apple kind of follows. It says first innovation has innovation level of R1, increment of R1, which is smaller one. And at that time, they say, you know what, we are not going to launch a product for a while. And the second innovation is a bigger innovation. So think of it as first product being iPhone 3S, then iPhone 4, which is a bigger innovation, then 4S, which is a smaller innovation, then 5, which is a bigger innovation, so on and so forth. So smaller innovation followed by a bigger innovation. That's the launch policy that will maximize firm's utility. So we kind of, whatever we saw in practice for a while, it kind of comes out naturally from theory also. That was kind of reasonably neat. So key determinant of this optimal launch policy is the fraction, that value divided by the price of the product and discount factor, which we call this as a long-term technological value. If long-term technological value is low, then firm should kind of exit the market. This is a fringe case, but it doesn't happen. If long-term technological value is not low, then firm should use a 2-cycle policy, minor launch and a major launch, right? So, which is very neat. And this is kind of another visual which says, look, these are the parameters, these are known. V, P, and deltas are all these known parameters. So for your problem, on which point you are falling on this in this 2D plane. If you are above this red curve, then you will have a 2-cycle policy. If you are beneath this red curve, then the single launch policy. This is just another visual saying, look, similarly, if your valuation B is somewhere in 1.2, then your first technology level is this blue point and second technology level is this green point. So technology gaps R1 and R2. Okay. So we kind of compared these two situations where we have on the go and we are pre-announcing. So pre-announcing, let's kind of now take a step back and think about this pre-announcing policy. So what did I say? I said, well, pre-announcing, firm pre-announces a sequence of technology levels. So as a solution, we are saying in reality, firm says, I'm going to launch my first product at technology level R1, then R1 plus R2, then R1 plus R2 plus R1, then R1 plus R2 plus R1 plus R2, right? But giving this infinite sequence of technology levels, that doesn't seem all that practical. So pre-announcing all future technology levels is not realistic. Is this necessary to implement the optimal policy? No, that's very useful. The firm needs to simply right? Firm needs simply to commit at the end of the minor launch, after the end of smaller innovation, like say 4S or 5S or so on and so forth, not to release another product too early or with too minor a technological improvement. So all that firm needs to do is whenever they launch a product that has a minor improvement, they should give the signal or announce that we are not going to launch a new product soon. We are not going to launch a product that will have a minor technology gain compared to this current one that we are launching. And that's enough to implement the policy that gives them more revenue. Right? The firm never needs to commit to launch a product by a given date, right? That's kind of that's understood simply because we are launching to we are committing to a technology level, and whenever that technology level is hit, that's the hitting time at which you kind of launch a product. Let me not sketch the proof of the theorem. Probably I incorporated this is simply because if some students are attending the talk, they at least get the flavor of type of tools and ideas that are used in these kind of economicsy, management science type of work, right? So we kind of reduce the problem to a smaller set by some clever arguments. Then we use idea of submodularity, saying, hey, this utility function of consumers are submodular, so you don't have to look at the entire all possible real sequences of the launch times. You can just look at subset of a given real sequence and things like that. And you can remove stochasticity. We had this expected value everywhere, but that stochasticity can also be taken care of by basically some standard probability calculations. That's not profound. These Brownian motion probability related things are reasonably well studied and given. Then once we have some simplified problem of the simplified optimization problem, it's simplified as in it doesn't have stochasticity in it, but still it has infinitely many constraints, right? So this is for I for all natural numbers. So these are infinitely many constraints. Then you relax the problem. You relax the problem, solve that relaxed problem, and then say, hey, this relaxed problem, so solution satisfies the original constraint things and makes life easier. So ideas from submodularity, regularity, and search, that makes life easier. Okay. So after all this jugglery, we can do, so far we assume that price is given, but in reality, price is, you want to charge the optimal price, especially if you're monopoly, you want to charge an optimal price. So we can do that also. We can do more math on top of this to say, hey, let's make price variable and figure out what's the optimal price. And once we do that, we find optimal price for both the information structures, for that on-the-go policy and pre-announcing. So we find optimal price for both. And then we compare. Then the comparison between revenues. Right. So most important things to look at is, this is the on-the-go policy numbers. These are pre-announced policy numbers. So when I want to compare revenues or profits from these two policies, what I want to do is I want to compare apple to apple. Right. So I want to compare apples with apples. Therefore, I look at optimal price in this situation and find the profit associated with that structure. I look at optimal price in pre-announced setting and look at the profit associated with it and say, hey, which policy is better, on the go or pre-announced? So pre-announcing was always better. Pre-announcing always gets you more profit. And the percentage gap between pre-announced profit and on-the-go profit it can be significant. 12% profit at times is a huge number in revenue management. These numbers are very big in when you consider revenue management side of this. Then once we did this, we do relax a model and do some of the extensions also. So far, what did we do? So far, we said there are this mass of consumers and everybody has base valuation as 1 unit. But market is actually heterogeneous, right? Market is heterogeneous. So we relax homogeneity assumption and we say, okay, let there be capital theta number of consumer classes. What do I mean by that? I mean, me as an academic, I don't use my phone all the time. But let's say you are a commodities trader who travels a lot. You want to use a phone which is super latest, which has high battery life, so on and so forth, because you do a lot of business on phone. So my base valuation is very different. It's way smaller than somebody who uses phone to do their to make their living, right? So when you have this market where there are people with different utility levels, with their base utility levels, what kind of policies work and so on and so forth. So in this case, we discretize the model, and we do away with the stochastic technology frontier assumption. We make model simpler by saying at time t, the technology level is just t. So zt is just t. Before this, we had zt is equal to mu plus sigma bt, right? Mu t plus sigma bt. But even in this, it's kind of a complex model, and you want to maximize firms utility subject to consumers maximize their own utility. So maximum subject to maximum with consumers constraints. So this is a complex problem. There you use this problem is Bilevel integer programming. So it's harder to solve, even computationally reasonably hard, because if you look at these constraints, right, w theta, x theta, these are binary constraints. These can take only 0 1 values. So if you wanted to solve this for small enough parameters, this is hard. Maximization subject to maximization, which an integer with binary constraint is hard. And you use these ideas from optimization, things like big M method, facility location results. Michael Gomans is he did quite some research in this facility, a little bit of research in this facility location problem based off MIT. Then you do primal dual and some other calculations to reduce it to a nice problem. This, although looks ugly, it's a nice problem, which has just one binary constraint and just one single maximization, right? So single maximization subject to a whole bunch of constraint is reasonably solvable. We solve this and say, hey, we find out what are the optimal launch times for certain type of market structures and such. Interesting observation is this one: value of knowing market composition. So imagine you are Apple, you are Toyota, you are Microsoft, right? And you want to understand what is market composition. If you assume that every customer is like Jigar, who has some base utility, and you launch product based off that information, you earn some profit. While market structure might be where there are just 20% Jigars, where they don't have as much base valuation, and 80% are commodities traders who use phone very frequently with very high valuation, base valuation. How much money are you leaving on the table, right? So that's where we compare that how important is it to know the composition of the market, right? So profit with complete information and the realized profit. So complete information is where you know the composition of the market, and realized profit is where you don't know the composition of market. And that can be significant differences between these two columns. So you understand, hey, knowing the composition of the market is reasonably important, and knowing the value of this information. In decision theory, people associate these type of things with they call it expected value with perfect information, or value of perfect information, so on and so forth. So you know how much would you be willing to pay for perfect information. So you can calculate this. Okay, so let's kind of take a step back and see what we did. So we analyze this optimal product launch policies by the firm when consumers are strategic. We analyze these games under two information structure. Information structure one was that on-the-go launch policy, where firm doesn't announce anything. Firm just launches the products on the go. What was the optimal decision in that information structure for the firm? Firm launches product at its optimal rate. Whenever the technological improvement is more than Z star, they launch the product, consumers buy that. We understood that if firm was pre-announcing, right? If the firm can somehow commit saying, hey, we are going to launch products which has technology level Z1, second product will have technology level Z2, third product will have technology level Z3, so on and so forth, they can make more money. So pre-announcing is better, right? And what was the optimal product launch strategy in that case? If there are low, this was unlikely case where the long-term value of the product was smaller, long-term technological value of the product smaller, then the firm will exit the market. If it's medium or high, this is the reality. Then they will employ this 2-cycle policy. That is, launch first product with a small improvement, launch a second product with a major improvement, then the third one with the smaller one, fourth one with the major one. All these numbers are calculatable and such. Right, optimal 2-cycle policy resembles Apple's launch policy somewhat, with minor launches followed by major ones. Right, and as we said, to implement optimal policy, announce after minor launch that there won't be any bigger one. So this is a feasible way of implementing this. So that's the talk in short form. I still seem to have exceeded time. Agnit, thank you so much.